So, next we will start about eigenvalue problems, and you have again read the eigenvalue problems in your previous classes. So, how you first define an eigenvalue problem? We define the eigenvalue problem as A x is equal to lambda x, okay, where A is A square n by n matrix, okay, x is a vector and lambda is a scalar. Okay. So, A is n by n square matrix, x is a vector, lambda is a scalar. Fine. So, what is the direct solution of this equation? What value of x will satisfy this equation? 0. So, if I substitute x equal to 0, it is satisfying, that means x equal to 0 is a solution, but we are not interested in that. We are interested in the solution for x not equal to 0, okay, x not equal to 0, fine. So, and for that what is the value of lambda, that we have to find. Okay. So, what we do for to solve this, what you have done in the previous classes, a minus lambda I, but determinant of a minus lambda I is 0, that you have done. Determinant of a minus lambda I as 0, or you are writing like a minus lambda I is equal to 0. No, this you had done. So, again we are doing y. So, you have done maybe up to 3 by 3 or 2 by 2 system. No. So, if it is 3 by 3, you can find this determinant very easily. So, if I give you 100 by 100. So, okay, first of all, if I have this determinant and A is 2 by 2, that you have solved. Okay. So, if I open this, expand this determinant, what you are going to get? What you are going to get first after expanding? A quadratic equation in lambda, fine, quadratic equation in lambda. So, you see I have 2 by 2 or 3 by 3, if I get, the equation will be of cubic, and remember our aim is to find lambda. Our aim is to find this lambda, lambda and x both, but in general lambda first, then x. Okay. So, I have to find this lambda first. So, this is quadratic equation for 2 by 2 system. If I have 3 by 3, cubic. If I have 4 by 4, 4 degree. If I have 100 by 100, I have 100 degree equation. I have 100 degree equation, and you need to solve that 100 degree polynomial and find the values of lambdas. So, is it easy to find if your system is large? So, again that is why we are studying here again the eigenvalue problem, where we can solve approximately the eigenvalue of a system. Okay, fine. This is the why we need. Now, again why we want to rate this A x equal to lambda x eigenvalue problem. For mathematics it is okay, physically from where we get this A x equal to lambda x. For any means application problem, can you tell that where we come up with this A x equal to lambda x eigenvalue problems? See, you have read in your class 12 in physics about degrees of freedom and spring mass system, or not? If I have two masses connected with springs, this we have read, or not? 2 by 2 spring mass system, and I have these masses m1, m2, and these are k1, k2 are stiffness of the springs. Then you started the motion of this system. Okay. So, Now, if I take the degrees of freedom like for this x 1, for this x 2, and you wrote, if you remember, the differential equations ODEs or not. So, if I do this, use the Newton's laws of motion etcetera, laws of motion etcetera. So, you will get two coupled ordinary differential equation, fine. So, now see this you have read in class 12 maybe. Now, this problem I can generalize to a civil engineering or mechanical engineering problem. How you see, if I do this, just draw this like this, see this is not exact, but that is generalized form I am telling, because see this is K 1, this is K 2, this is M 1, this is M 2, fine. So, this system, you know that I can generalize this to this, fine. So, what is this? This is maybe 2-story structure, 1 dimension, 3 dimension, it is 3 dimension, but I can generalize this like this. So, if I write the differential equation etcetera, so what you will get? You will get 2 by 2 system, means I am writing directly using Newton's law etcetera, Newton's laws of motion. You will get this mx double dot plus kx is equal to 0 type, this type of differential equation, okay, fine. So, this type of differential y 0 I am not taking the force, fine. So, you see from here to here to here, okay. So, what you are getting? You are getting actually from the physical or engineering system to a mathematical problem. Now, I have to solve this differential equation. This is ODE, ordinary differential equation, mx double dot plus kx equal to 0. X double dot means d2x by dt square. Okay. So, in the next class I will show that this problem actually is nothing but that eigenvalue problem. And why eigenvalue problem, that I will discuss in the next class, that this lambda is actually nothing but the natural frequency of this system, and we need to know before design of any system what is your natural frequency, what is your deflected positions, means eigenvector or the mode shapes etcetera. So, these two are very important with respect to your practical problems, that he was telling other equation of physics, maybe Schrodinger equation etcetera. There also those lambda and x designate different thing, but you need to find the eigenvalue and eigenvector. Okay. So, those are the various applications. So, whatever we are seeing here, those are with respect to some application problems, and that is why see I have 2 by 2, 2-story. If I want to build a 50-story building, so I will have 50 by 50 matrix. See here this m and k are 2 by 2, that I will write in the next class what are those m and k. Okay. So, for 2-story I have, or 2 spring mass I have 2 by 2, this is 2 by 2 here, fine. But if I have 50 by 50, 20 by 20, you will have accordingly the order of the system will increase. Okay, fine. So, these are the basics, that why we need, what we are going to do. Okay. And now, next is how to find these eigenvalues. So, this I will convert this ODE to eigenvalue problem, then you will understand that why we need to study this eigenvalue problem. Okay. So, thank you very much.